for one, we're dealing with using logical reason. We're talking about 5 different, well actually 4 real different statements, and then a contrapositive which kind of blends. It has you have to do a truth value for it, which we'll talk about. The conditional, the converse, the biconditional, and the inverse. Okay? I'm sorry, the biconditional you use a truth value for. So you kind of have this if and only if piece in the middle. Okay? So what I need you to do is copy down those, and notice I use highlighters to show how things move around. That's really what's happening in these statements. Our portions, what we call the hypothesis and the conclusion, are moving around. And then we use truth value to determine if we're going to write a biconditional. You'll need a textbook to help define those other 3 things. Okay, at least get an idea of them. And I'm going to give you guys about, 7, 8 minutes or so to kind of work on that with the groupies. And then, while you're doing that, I'm going to get rolling. Here we go. Bethany.
I'm confused on how to define hypothesis and conclusion because it doesn't say. All it says is that every conditional has those.
Yeah, hypothesis and a conclusion. It might make a little more sense once we actually do a problem. Okay?
How would you define that on your sheet?
Well, sometimes your definition, it's good to have an example for you. Okay? So let's actually try some of these problems. Let's go through. We're going to kind of keep that up there, and I'm going to cover hypothesis, conclusion, and truth value while we go through some problems together. Okay, so this is going to be off your assignment today, but you can write these down into your notes. These are good ones to have. First, for each statement, write the converse, the inverse, and the contrapositive. So this is our statement, our original statement. Okay? Our original statement there, it's our that's called our conditional statement. If A, then B. This is A. If a square side is 5 centimeters, then its area is 25 square centimeters. This would be considered your hypothesis. Unbelievable. Hypothesis. This would be considered your conclusion. Okay. Hopefully you write hypothesis a little neater than I did. But. All right. So if A, then B. So if I'm writing the converse of that, notice the converse just flips the hypothesis and the conclusion. Okay. So if I'm looking at those, that becomes then if B, then A. So these two change spots when we're doing a converse. Okay, so I want you to go ahead and write down the converse there. Converse. So the converse becomes if its area is 25 square centimeters, then a square side is 5 centimeters. Okay, so we switch those around. So first of all, if I've got my conditional here, and I'll quickly write out the converse there. Okay. First of all, is the conditional true? Is that a true statement?
Yeah.
You sure? The square side is 5, then the area is 25. Is that always true? Yeah. Yeah, it is true. Okay, 5 times 5 is 25. Okay, if the square's area is 25, then its side is always 5. Is that true?
Yes.
Is there any situation where that wouldn't be true? No. So if both of these things are true, you've now determined the truth value. Okay, you've said, hey, this is true, that's the truth value of that. This is true, that's the truth value of that. That's how you determine truth value. You just, hey, is the statement true? Okay, if both the conditional and the converse are true, then you can write a biconditional. And notice the biconditional takes the hypothesis and it says if and only if, and then it puts the conclusion. So I want you to go ahead and write a biconditional for this statement since these are both true. Biconditional there. Let's see, that's what I've got there. Square side is 5 centimeters if and only if its area is 25 square centimeters. Agree? Yeah. How many got it right there? Okay. All right. You just sit on my desk. Thanks, Hannah. Okay. I want you to write an inverse. Actually, before we go to that, is there any other questions on that? Notice in the inverse, yeah.
Well, you can only write the biconditional if both of them are true, right?
Correct. You can only write the biconditional if the converse and the conditional are true. Okay, notice the inverse adds the word not. Okay, so when we're dealing with an inverse, all we're doing really is putting the word not right here. If a square side, well, maybe not right there. If a square side is not 5 centimeters, then its area is not 25 square centimeters. Logan, you got that? Yeah? All right. Why don't you explain a contrapositive to me then?
Yeah, if something is then B, then it's not A. So if its area is 25 centimeters, then its side is not 5 centimeters.
Okay, good. You just flip those around. You take this piece and you move it around there. So after you negate that, that's called negating it. Okay, when you negate it, in other words, you make it a negative. Okay, you put the knots in there. That changes it to a inverse. And then when we flip them around, that changes it to a contrapositive. So it's really just moving statements around. Yeah?
Could the biconditional be negative for both false?
No, we're not using we don't do a negative biconditional. Yeah. I haven't never dealt with that though. I've never tried that. No, that wouldn't work. It wouldn't work out on all of them. No. Okay. All right. You guys think you have it? Mm-hmm. Yeah? Okay. Hey, can I borrow your book? There's a pretty good table of this in the book. I think a really good example, and it actually lays out some examples. This is on page 185. If you need a page to reference, maybe throwing it into your notes. But they lay out the statements. They show the moving of the hypothesis and the conclusion. Okay? So, and they put it in color there, which helps out a bit. And then there's a comic on here you can read later, just in case you're interested. That's not too funny. All right. I don't get it. Okay. That's what we're doing today. Man, some fun stuff. Any questions on it? I'll leave that up there for you to reference.